Good morning. We're going to be looking at the Java constructor and how we can use it, as well as some examples of how it works and the design and basically the structures that go along with it. We're going to take a look at that today. Here we have the role of the constructors. One of the biggest things the constructor needs to do is it needs to initialize all the data members of the class, because the constructor is basically what it's doing is it's building the object, hence the construct, the root word of the actual word itself. And as the initializing the data members, one thing that really needs to make sure that you keep in mind is that if you don't initialize the data members in the constructor, by default, any object data member you're working with is going to be null. And if you have a null data member, you're more likely to get a null pointer exception. That's a sad face all over the place. We don't have any sad pandas. So we want to avoid those null pointer exceptions, and so we need to explicitly initialize our data members. That's the job that a constructor should be handling. Also, if you're dealing with a primitive, like an int, a double, boolean, char, whatever, those are the default values of either 0 or false. Not really the most descriptive things. We want to also make sure we explicitly initialize those as well. Those don't harm the code as much, those just lead to logic errors, but we want to make sure we don't have bad data inside our objects when we create it. The way we want to make sure we handle it is by looking over all of our data members in the declaration section, aka the top of the file, if you're following my design style, that you look over all those data members in that declaration section, and then inside your constructor, you initialize them in the exact same order. So you go boom, 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 boom in the declaration section. So you go boom, 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 boom in your constructor, initialize all those values. Oftentimes, when we're working with a constructor, we're going to have a parameter or a series of parameters. Those parameters are there for us, so use them. Again, if you're especially working with the AP computer science side, if you're given parameters, always use those parameters. They are there explicitly to give you information so you can use it inside your code. And when you're writing code or being given code as an assignment or as a project or something that you're working with, you need that information. So if you're given a parameter, make sure you explicitly use it correctly inside your constructor. It's there to be used. I myself explicitly use the this.datamember equals parameter name, even if they don't match. So if it's this.car equals my car, because it's my car as the parameter is what we have up there in the initialization section, in the parameter sequence up on top of the file, that's okay, because I explicitly know that I'm assigning to this one right here, the class that I'm working with. And so this.datamember is a really nice way to make sure you're explicitly assigning the data member the value appropriately. Now again, the object of a constructor is to build or create the object, and so we don't have a return statement. This isn't a method. This is one of the biggest confusions that people often have when they're working with Java is they think that, oh, it's a method, so it should be public void constructor name. No, it's a constructor. It's just visibility and the constructor name, and 99% of the time it's just going to be public. So most custom objects that we create inside our projects are always going to have a constructor. Otherwise, we just get the implicit constructor of Java, which is a default no parameter constructor that does nothing. It just says, boom, there's an object. What's about all the data members? What all the stuff we need? Well, we don't have that. It's all null and blank. No. We don't want null and blank stuff. So we explicitly need to make sure we practice writing and designing constructors so we can initialize our data members and use them effectively. And so let's go take a look at that right here. Our definition syntax. First thing we have is the visibility modifier, aka public or private. Now, when we're working with a constructor, 99.99999% of the time, it's going to be a public constructor. When we're dealing with basic to intermediate and even most advanced projects, you do not need to have a private or protected constructor because a constructor is not inherited, so protected is out of the way. And private, the constructor is something that you explicitly as the programmer are using. Other things don't need to worry about building that, so you don't have to worry about restricting build access to just the one single file you're working with. And so with that as the case, our constructors are going to be public 99.9% of the time. The name has to match the class. Capitals matter. So make sure when you're designing your class that you actually remember that rule of Java design, that it's always starting with a capital letter and explicitly the class, the file, and the constructor. Those three always have the exact same name. Makes it really easy, again, like I said earlier, to avoid any method confusion, because if it starts with a capital instead of a lowercase, you know that you're working with a constructor and not a method. So this is a good this is a good idea in the way of design principles to always make sure that your variables and lower methods always start with lowercase letters, and only constructors start with a capital. Great way to keep your brain sorted. Now, talking again about parameters, we can overload constructors, aka we can have more than one constructor in the same file. And so we have our default, aka the no parameter constructor, great for a standard instance. However, we can have multiple constructors. We can customize and create our objects with different parameters, like a constructor with an int, a constructor with a string, a constructor with an int and a string. Great, cool. We'll see a couple examples of those in just a bit. The parameters that are used are there to actually supply information to the object. Now, those can be a direct assignment or it can be a calculation-based assignment. Direct assignment is where the variable just gets directly assigned into a data member. A calculation would be, say, for example, you're going to extract some information from a specific parameter and then use that to assign into a data member. Great way as well. We'll see some examples of that when we look at the 2016 question for APCS as well. Here we have a couple examples of constructor syntax. On the left, I have a default no parameter constructor. We know it's a default not only because I have this.name equals default, but because it's just using the same basic approach, just the empty params. That means it just creates an object, and I'm explicitly assigning a value to every single data member in my marshmallow monster class. Also, when I'm assigning to my primitive, I assign a value that's explicitly not just a 0, because that way I know that it's a default constructor, and if I retrieve a value from that, if I want to do any tests or evaluations of actual assigned values on that, I know it's not the default value, because sometimes on a monster, they don't have bias. So 0 would actually be a good valid value, and I want to make sure that that's actually been explicitly assigned. Negative 99, you can't have a negative amount of an actual thing. You can have 0 or above. And so it's a great way to actually explicitly say that, oh, I know that what this is going to be. And then we also have inside a double case, we have double negative infinity. Also, you can't have a negative amount of things. And so by having that negative that's explicitly defined as something that can't happen, is a visible as an actual value, we know that we have a default value, and then we want to customize that later on in our code. And so that's one of the reasons why a blank constructor is usually not always the best option. We want to actually look over here on the right and look at our more expanded constructor. We can supply parameters that build our object and customize it so we know exactly what's happening with that. And so here we have a customized constructor with a lot of parameters with string, boolean, int, and a double. And we use the explicit variables where we're saying this.name is name, this.hasNob is hasNob. And so I'm using a direct match between the name of the parameter right here and the class variable this.name. So I explicitly assign them from there to there. However, I can also use that same approach with this one where this.iCount equals i's. I still use the this dot even though I'm not required to because it has a different variable name. I'm doing that because by using that same structure, by explicitly identifying them and talking about this dot, I am always knowing inside my code which variables I'm referring to, and I always make sure that I have the correct variable on the assignment side of the operator rather than on the retrieval side of the operator. And it's just a really good, easy design practice. You can make sure you do things properly all the way through. Now let's take a look at some helper methods. Helper methods are amazing, especially as you get to more advanced and more complex projects. You often want to farm out some of the work that happens. The example I give in class of this is, say for example, the example I give in class of this is Tom Sawyer and farming out the job of painting the fence to his friends and loved ones. He doesn't want to do all the work, so he gives little bits of job out to other people so they can work on it for him. By having other people do little pieces of the action, my code can get simpler and smaller, and it's a little bit easier to understand because I know exactly what's happening inside this chunk. But also what really helps it and make this happen is I can reuse the code later on or inside another constructor, aka code reuse, a great idea for design principles. So the 2016 question, like I mentioned earlier for APCS exam, the free response question number 1 called random string chooser, one of the things you had to do is you had to find a way of using information from an array without harming the array. And a great way to do that would be to pass that array to a helper method, use that helper method to build an array list that has the values inside it, so that way you can manipulate that array list and not harm the actual original data, but also that helper method can then be called internally and recreate that information as needed. It's one of those great things, again, so you can reuse information, so you can do cool things and do more stuff with your project. It's also really good to populate data structures. We have that example over here with my chatbot code. I have a helper method called build the list that I'm calling inside this constructor. It's also called inside the default constructor right here. And the build the list helper method goes through and adds a whole bunch of responses to the response list, as well as a whole bunch of spooky items to the spooky list. And so what that does is I can have that pre-built data structure handled. Instead of having a giant massive huge pile of code inside my constructor, I just call the build list helper method, and that goes through and actually does all the work for assigning values into the data members so I can use them later on. Again, it's also really helpful for reusing code. We can't say enough how often it is to think about how you can better make your code be a little bit cleaner, organized, so when you come back to it and look at it again, it makes sense for you later. Like I said with the 2016, it's a great way to use or view data you don't want to destroy, so you can pass that data member as a parameter, extract the information you want from that parameter without harming it in the first place, and then assign it to a new data member or some other value and calculate information from that. Reusing code is fantastic. We want to make sure that we actually design how we're going to look at our code again in the future, because by having code that we can reuse, like this build the list method, if I need to do something and change the actual structure of that list, remove it, recreate it, or repopulate it based on some other action with the user, recreate that object based on some other interaction within the program, I can actually have that method build the list, which will go back through and re-add those component pieces right back into the structure without having to worry about this. And so this is one of those really amazing things. By having a helper method, it makes it so I can redo or make more actions happen because I've got something extracted out and I've thought about how I can use that design to do more stuff in the future. And so a constructor with a helper method is a great way, again, to make that happen. We also have to work with inheritance when we're talking about constructors. On the right, we have the example of an inheritance of a GUI system with a JFrame class. And so if we have a subclass, aka sample frame, which is a subclass of JFrame, the first line of the constructor, as we can see right here in the blue highlight, needs to be a call to super. So if we see extends, we should also see a call to super as the first line of the constructor. That should be an automatic thing. As soon as you see extends, when you write the constructor, call the super parent class. And so we want to make sure we do that right there. We do want to make sure we also check for any parameters of the parent class. Now the JFrame constructor doesn't have any required parameters, so I don't have to pass them parameters inside my constructor call right here. However, many classes in their parent class often do have parameters, and so you want to make sure you keep that in mind, that when you're using an inheritance relationship, that you know if there are any parameters, you can make sure they're passed appropriately when you call the super as part of your constructor call as well. Now, we also have to remember that the rule of inheritance is that we don't have any access or reference to the private data members. We have access to all the public information, so we can use the setters and the getters to retrieve those values. If we're working with an inheritance structure and we have a parent class that we have to refer to, we have to use the setter methods of that parent class to access the internal data members. We can't just simply assign into it. That's private data, and that privacy is still maintained. So we have to make sure that we can assign into it by using the setters. So remember, when we're using inheritance, we use setters, not just direct assignment into that. And that's just a basic rule when we're talking about how to actually assign and retrieve values from that, because we only retrieve the public information when we're using inheritance. Now, I'm explicitly saying it right here, we do not inherit constructors. Because we don't inherit constructors, we have to call them using the super call. And that's what we're doing right there inside that blue box in the middle of the, at the top of the sample frame constructor. Because constructors are not inherited. So I can't call the parent class constructor, say constructor call or whatever. I use super parens, and that's how I call the constructor of my parent class. When we're implementing the constructor, aka we're actually using inside our code, Java requires us to use the new keyword. I'm explicitly saying this aloud. It's printed right there on the screen. We've probably heard it a few times before, but you have to use the new keyword. When you're using the constructor, it won't even compile. It'll give you a nice set of warnings about that. We don't want to hear about those. We have to make sure we use the new keyword. It's automatic. Now, when we're using a constructor, we can assign those into a variable. It's either of the type that we're working with or its parent class. And so we have right here animal temp is a new cat. So that creates a new cat object, and it stores it in the temp variable, which is of type animal, where animal is a superclass of cat. We can also explicitly say that cat my cat is a new cat because cat is a cat, and I can assign the variable into that type as well. So either into the same type or a parent type, something that can actually hold that same structure. We also have the ability to use an anonymous instance. An anonymous instance is when I don't use a variable at all. This is most often the case when we're working with lists or arrays and we want to add a default value or a customized value directly into a list that we can use and access later. As you can see right here, I have parking lot cars.add a new special car. I'm calling the special cars constructor, assign it directly into the end of the list, and then moving on. I can also do it with an array where zoo penguin's subindex is equal to new emperor penguin. Whatever my index value is, I'm putting new emperor penguin right at that spot. I don't have to worry about actually giving it a variable because I don't need to refer to it as a specific instance right then, because I can extract it from my structure and then use a variable to refer to it as I need to in that spot. However, if I just use a constructor without the keyword null, I just have without a call to the constructor, I just have the variable for that. So zombie head my zombie, the only thing I can ever refer to in my zombie, if I don't ever assign equals new zombie head into that, all I have inside there is null. And that's going to lead to a null pointer exception. So again, in review, we want to make sure that when we're working with a constructor, we always use the new keyword, we remember how inheritance can work with that, and we want to make sure we go back through and look at the design of it to make sure we implement all of our data members to initialize all those values so they're appropriately used so we can have a good constructor. Thanks, and have a great day.